Jai Ho students, welcome back to SKCBSE's DG Vidya class session. Dear students, in previous class we have discussed the decimal expansion of rational numbers and irrational numbers. So first we find only the decimal expansion of rational numbers. In the next class we discuss the decimal expansion of irrational numbers. Clear? So here these are the questions which are related to the decimal expansion of rational numbers. As we have discussed in yesterday examples, that finally we got one conclusion that the decimal expansion of rational numbers is either terminating or non-terminating repeating. Clear? So rational numbers have either terminating or non-terminating recurring decimal expansion. Terminating means division process will end for some steps. Non-terminating means the division process will not end for some steps. If you go on doing division, the division process will not stop. It will not end. Clear? And some digits will repeat at quotient. That's why the decimal expansion of rational numbers is either terminating or non-terminating repeating or recurring we used to call. Clear? So they have given 4 rational numbers. Actually they have given in exercise 1.3 6 rational numbers. 2 already we have discussed, 2 already we have seen, and in this remaining are 4. So first rational number is 1 by 11. Second one is 4 integer 1 by 8. 2 by 11 12. And fourth one 329 divided by 400. We have to check what type of decimal expansion each rational number has. So shall we solve? Okay. Take first one. First one is 1 divided by 11. 1 divided by 11. So here we have to divide which number? 11 by 1 we have to divide by 11. So 1 we have to divide by 11. Is 1 divisible by 11? No. So here we have to take add quotient decimal point. Then here take 0. So 10 also smaller than 11. Again 1 0 you should take, here you take 0. Clear? 11 9s are 99. 11 9s are 99. So what will remain? Again 1 will remain. Clear? Then 0 you put here. 0 you take here. Clear? So next what you should take? 0 first. Here you have to take 0. Then 10 is not divisible. So 10 is smaller than 11. Again 0 we have to take here. 100 it will become. Yeah. So 11 9s are again 99. Remainder we obtain 1 only. For each and every step after doing division, remainder we are obtaining 1. So this process will not end for some steps. So which are the digits repeating here? 0 9 0 9 0 9 0 9 0 9. So it will be gone repeating. So that's why this rational number has non-terminating repeating expansion. That is decimal expansion. By this we come to know that this rational number has non-terminating repeating decimal expansion. This can be written as what we can write? 0.09. So what are the digits repeating? 0 is repeating, 9 is also repeating. So for both 0 and 9 we have to put an arrow mark. So 0.09 bar. So 090909 it can be written. So this type of rational number, this rational number has non-terminating repeating decimal expansion. So what you need to write here? This rational, this division also we have to do. Then we have to write this one. Last division. What we have to write? This rational number. This rational number. Which is that rational number? 1 by 11. Rational number. This rational number has what type of, will it end? Division will end? No. That is has non-terminating. It will not terminate. Non-terminating. And which are the digits repeating? 0909. Yeah. And recurring. Recurring. It is also called as repeating. Decimal expansion. Decimal expansion. So first one is non-terminating and recurring decimal expansion. This rational number has non-terminating, recurring decimal expansion. Clear? Understood? Now you take second question. What is that second question? In that question, what they have given? First, the given rational number we have to write in the form of p by q. That is 4 integer 1 by 8. So we know how to convert improper fractions as mixed fractions and mixed fractions as improper. So it is mixed fraction. This mixed fraction we have to convert as improper fraction. 4 8s are 32. 32 plus 1, 33. 33 divided by 8. So now what we have to do? We have to divide 33 by which number? By 8. 8 4s are 32. 8 4s are 32. 32 minus 30. 33 minus 32. 1. Then go to decimal point, take 0. 8 1s are 8. Yeah. So 10 minus 8, 2. Again 0. 8 2s are 16. 8 2s are 16. 20 minus 16, 4. Again take 0. 8 5s are 40. Here remainder is 0. No more division is continued next. Why? Because we obtained remainder 0. Then we can say this rational number has what type of decimal expansion? Terminating. Yeah. So this can be written as 4.125. We have written this in the form of decimal form. And what type of decimal expansion this has? What type of decimal expansion this has? This rational number, that is direct I write 33 by 8 or 4 integer 1 by 8 has terminating, very good, terminating decimal expansion. Terminating decimal expansion. Yeah, because remainder we obtain 0. Next process is stopped at this step. Yeah, so we obtain 4 integer 1 by 8 as 4.125. So this is what type of decimal expansion? Terminating decimal expansion. Have you understood this? Okay. Next, third question. In question number 3, what all they have given? In question number 3, they have given 2 by 11. Third question is 2 divided by 11. So we have to divide 2. We have to divide 2 by which number? 11. We have to divide by 11. So here no 2 is smaller than 11. So what we have to take? Decimal point we have to take. Then take 0. 11 ones are 11. 20 minus 11. 20 minus 11 is 9. 20 minus 11 is 9. Here again 0 to take. What we get? 11 and 19 is 11 8s are 88. 11 8s are 88. 90 minus 88 2. Again 0. 11 ones are 11. Here. So subtract 20 minus 11. Again 9. Again take 0. 11 8s are 88. Here again we obtain 2. So what are the remainders we are obtaining? 2 and 9. 2 and 9. So here remainder is not equal to 0. Again if you do, go on continuing the division. So we won't get the remainder 0. This process will not end. Division process will not end. You won't get the remainder 0. That's why this rational number has non-terminating and. What digits are repeating here? 1 8 1 8 1 8 1 8. So 1 and 8 digits are repeating. Therefore, this rational number has non-terminating and repeating decimal expansion. This can be written as, how we can write? 0.18 bar. 18 means 1 and 8 are continuously repeating in the quotient. Therefore, 2 by 11 has what type of decimal expansion? Non-terminating repeating. Yeah, this has, that is 2 by 11 has what type of decimal expansion? Non-terminating and recurring. Has non-terminating and recurring or repeating decimal expansion. Here, so non-terminating, repeating decimal expansion this rational number has. Now at last question. Now we have come to last one, that is 329 divided by 4. 329 divided by 400. Yes. So now what we have to divide? 329 by which number? 400. That is 329. Yeah. So here 329 is smaller than 400. Then take decimal point at quotient. Then here we have to take 0. 400. See, 4 8s are 32. 400 8s are 3200. Yeah. 3200. What remainder we obtain? 90. Sorry, 90. Then take 0 here. 400 2s are 800. 400 2s are 800. 900 minus 800, 100. Again take 0. 400 2s are 800. 400 2s are 800. So what will remain here? 200. Now take one more 0. 400 5s are, that is 2000. 400 5s are 2000. Here we obtain remainder 0. Here remainder 0 means this rational number has terminating decimal expansion. This can be written as 0.8225. That is 329 divided by 400 has what type of decimal expansion? As terminating decimal expansion. As what type of decimal expansion? Terminating means remainder we obtain 0. Here. So in the next class we discuss some more examples related to irrational numbers and rational numbers. Here, so till then, take care. Jai Hind.